Okay, right. So before holiday, okay, the last subtopic that we have learned was the acid-base titration curve and indicators. Okay, all right. So this was the last subtopic, and in fact, you have been introduced. I mean, you have learned, okay, on how to calculate the pH at equivalent point. Okay, so the most important thing that you should know in acid-base titration, that you have to calculate the pH at equivalent point. That would be the most famous question that will be asked in the exam. Okay, all right. So you should know how to calculate the pH at equivalent point. But before you could calculate the pH at equivalent point, you should know what is present at equivalent point. And why is it called equivalent point? Equivalent point. Equal, the word equal, the root word is equal. Equal means what is equal at this equivalent point. What are actually in equal amount, okay, at this equivalent point. So at equivalent point, we have the mole of acid is equal to the mole of base. Okay, so when these two have the same mole, these two will be totally consumed. That means they will be neutralized by one another. Okay, they will be totally neutralized, and there's no acid and also there's no base. So when these two neutralize, it will produce product. The product is what we call salt. Okay, so during or at equivalent point, the species that present is the salt, only the salt and water as well. Okay, so salt is the species that present at equivalent point, and the pH that we are calculating at equivalent point is actually the pH of the salt. Okay, it's the pH of the salt. We don't have acid and we don't have base at this equivalent point. Okay, and we know that salt, we have several types of salt. Okay, we have not only neutral salt. Okay, we have acidic salt and also basic salt. Okay, all right. So the easiest way to determine whether the type of salt produced would be from the type of acid or base reacted. Okay, so itu paling cepat that we can determine the type of salt produced. At least we know whether it is an acidic or basic salt. So if it's an acidic salt, that means we should, at the end of the day, when we calculate, the value of the pH should be less than 7 if it is an acidic salt. Okay, so at least we have that idea first before we proceed to calculation. Okay, this is just to check whether you are on track or not, ataupun you calculate tu betul tak the final value tu. Okay, so kalau you are supposed to get acidic salt, which is pH less than 7, but at the end you got 8, pH is equal to 8. So that's definitely something is wrong somewhere. So you have to recheck and redo. Okay, all right. Then the pH at equivalent point will be the famous one, and then other than that, you should also know, okay, how to calculate pH at the initial. Okay, in the initial part, that means before the titration starts. Before the titration starts, that means you have to know what's in the flask. Okay, so which solution is placed in the flask and which solution is placed in the burette. So the flask, okay, in the flask is where we place the pH meter. Okay, that means initial pH should come from the solution from the flask. Okay, that one also you have to identify, because the initial pH depends on the solution in the flask. Okay, all right. So moving on. Okay, we have tried out the calculation involving the pH at equivalent point, which is this question. Okay, So this is the example, and we have two options. Okay, as always, we have two options. One is by using the ICE table, the conventional way, okay, the ICE table, and also the Ka expression. Okay, so we are going to solve for X. X is also equal to concentration of H3O+, and then we insert into the formula. So alternative to this, we have this alternative ataupun simplifying method. We can just simply insert into concentration of H3O+ is equal to square root of Ka times C. As simple as that. Okay, so if you are using this simplifying assumption, okay, you can also have the ICE table. Okay, tak bermakna you pakai this alternative method, you tak boleh pakai ICE table. No, ICE table is very, I mean, the general. Okay, you may use, ICE table still can be used even though you are using the alternative method, because ICE table allow us to see everything. You have the equation, what actually happening, and then you have the step. Okay, initially we have this concentration, and then these are the change, and then at equilibrium, and then you can simply insert into this what do you call this, a formula. Okay, this method. Okay. Okay, so I believe that we have discussed this one, okay, before we had our holiday. Betul tak, guys? Saya percaya yang saya dah discuss this one. Check.
Dah, madam.
Checkpoint
tuan.
Okay, I remember that last time we did this one together. Okay, so we have one more checkpoint, which is checkpoint 13. Okay, so let's do it together. Okay, I hope that everybody has completed this checkpoint. Okay, so saya mungkin akan sedih kalau siapa yang tak buat tu, ataupun saya marah. Okay, so let's just assume untuk this checkpoint that everybody has done it, and we will discuss it. Okay, all right. Okay, let's go through the question. 20 ml of sample, 20 ml sample of 0.115 molar CH3NH2 solution was titrated with 0.1014 molar HNO3. Calculate the pH at the equivalent point, and the Kb of the base is given. Okay, all right. So the target is to find the pH at equivalent point. Okay, all right. So before we could do that, before we proceed to the calculation, let's just have an idea on what to do next. Okay, so the first step would be good if you could predict. Okay, you could predict the pH at which the equivalent point apa nama tu is determined. Okay, dekat mana sebenarnya pH at the equivalent point tu? Is it less than 7 or is it more than 7? And obviously it will not be equal to 7, because this is not between strong versus strong acid versus strong base. Okay, obviously. Okay, all right. So this is CH3 and CH3NH2 is what, guys? Is it an acid or is it a base? Guys, respond please.
Base.
Sorry?
Base.
Base. Okay, base. Okay, what type of base is this? Okay, it's a weak base. Okay, all right. So it is a weak base. And then, kalau tak familiar with this one, okay, maybe you are very familiar with this one. Okay, so HNO3 is categorized as strong acid. Okay, so hopefully by now you should have memorized all the 6 acids, if I'm not mistaken, 6 or 5. Okay, don't get confused with HNO3 dengan HNO2. HNO2 is a weak acid. HNO3 is the strong acid. Okay, nampak NO je terus je strong. No, HNO2 is weak. HNO3 is the strong acid. Okay, and then since we have nitrogen, and then it is a neutral, apa nama tu, species. That means there's no charge. Okay, so therefore this is base. Okay, so this is weak base and this is strong acid. So if we have weak base plus strong acid, it will produce a salt that is, what type of salt, guys?
Acidic.
All right, thank you. Okay, it will produce a salt that is acidic. Okay, we have an acidic salt. When we have this acidic salt, based on our prediction, that means the pH should be less than 7. And one more thing, since we have an acidic salt, at the end of the day, when you have to write the equation, you should be producing H3O+. So what acidic, kan? How do you prove that it is an acidic solution, acidic salt or whatever? Okay, based on the equation, it produced H3O+. And not only that, since it produced H3O+, the Ka and the Kb. Okay, so you need to produce H3O+. That means later, if it is needed, you have to use Ka. You need the value of Ka, not the value of Kb. So what is given to you is the Kb. See? So bila you nampak, oh, H3O+, then I need A lah, acid, not the base. But what is given to me is the base. I don't want this, but I need to use this to find the Ka. Okay? Alright, so that is why this, strategy is very important. It gives you the brief idea on what to do next. Okay, it guides you. So once you have this H3O+, later on, remember you have to calculate the pH, kan? So pH is equal to negative log H3O+. Once you have determined the H3O+ just now, okay, you can simply insert into the formula. Okay? Alright, so that's the plan. The idea lah, because to, okay, so let's have a blank slides here. Okay. Okay, alright, so let's start. Nak start dengan apa dulu? Okay, kalau to me, I prefer to start from the equation of the acid and base itself. Okay, kadang-kadang kita tak tahu nak start kat mana, kan? So kalau saya personally, I would prefer to start from the acid and base punya equation. And then from there, kita grow, kita develop, atau kita proceed to the next. Kita akan ada idea lah somehow. Okay, cuma starting point tu is very important. Okay, alright. So let's start from the acid and base itself, the neutralization process itself, CH3 and H2. So this is the weak base, react with strong acid. Okay, so remember this is only forward arrow. So this reaction only involves the forward arrow. That means the one direction, the forward direction. Okay, it's not reversible. So by now you should have memorized the type of reaction that have forward reaction saja. There's no the reaction proceed only forward reaction saja. Maksudnya it's not reversible, it is irreversible. Apakah contoh-contoh reaction yang irreversible? Contohnya neutralization, okay, between acid and base, dia satu arah saja. And then salt dissociation. Okay, salt dissociation. Salt dissociation is different than salt hydrolysis. Salt dissociation means salt tu dia dissociate into an ion and cation. And then we have to choose from these two which one will be hydrolyzed. Then baru dia undergoes hydrolysis. Itu reversible. Okay, don't get confused. Alright, and then what else yang forward direction? Strong acid, strong base dissociation. Strong acid and strong base dissociation. Maksudnya it will only proceed to a forward reaction. Okay, it will not be reverse. Okay, so those kind of thing you kena bear in mind lah, because if you somehow use the reversible arrow, that means the whole equation is wrong ataupun incorrect lah. Dia tak represent the reaction well. Okay, so please kena benda-benda macam tu kena alert lah, kena aware. Alright, so the product will be CH3 and H2. NH3. Okay, this is an ion. Okay, NH3, NOI. NO3. Okay, NO3. Okay, there's no water jangan ingat every time buat reaction tu neutralization mesti produce water, not necessarily. Okay, you must be familiar with this one. NH3 plus HCl. So what will be the product, guys? NH4Cl kan? It's actually almost the same. Okay, so ini nitrogen kan? So okay, let's just use NH3 as your reference. How would you draw NH3? So this is how you would draw the NH3. That means by default kan, nitrogen is attached to 3 hydrogen and it has 1 lone pair. So this is the neutral state of ammonia. Okay, alright. So bila dia jadi begini, what actually happens that dia ada 2 hydrogen and 1 bond tu dia attach kepada CH3. This one. See, dia just ganti one of the hydrogen with CH3. Okay, so jangan rasa intimidated by apa benda yang dia bagi dekat situ. So you use NH3 as your reference. Kadang-kadang dia boleh bagi macam ni tau. Dia boleh buat macam ni. Rasa macam scary gila dia punya equation dia tu. NH. This one 2, this one 1. Okay. So macam mana you nak imagine this one macam takutnya. You jadikan ammonia tu as reference. Supposedly dia ada 3 hydrogen kan. So now instead of 3, it has only 1. It's just that the rest tu dia ganti dengan CH3, CH2, CH3. Okay, CH2, CH3. That's all. Sama juga, dia tetap ada 1 lone pair. It's just that hydrogen is now being replaced with other alkyl group. Okay, itu saja. So yang ni kan dia combine NH3, HCl, so dia jadi NH4. Okay, remember kalau NH3 dia akan need this one later. Bila you pecahkan dia kan, this is salt kan, dia akan produce NH4 plus dengan Cl minus. So dia akan accept the hydrogen, the extra proton from the acid. So this one later akan jadi, nampak, from 2 jadi 3. See, this one just now mana tadi? NH4Cl from 3 becoming 4. See, bila dia accept proton, dia akan jadi plus because the lone pair is used to form a bond with the proton just now. That's why dia hilang the lone pair. So dia hilang the electronegativity tu, so that's why they become positive. Okay, so ni tu lagi satu knowledge yang you kena tahu. Not all reaction produce, not all neutralization reaction produce water. Okay. Okay.
Madam.
Yep.
Kita tak boleh pecahkan dia jadi 3, madam.
Apa dia? T3?
Dia tak. Macam contoh dia jadi CH3OH plus H2O plus N2.
CH3OH.
Bukan, dia punya produk.
Ada 3 produk.
Sebab mostly saya tengok kat Google punya kan, dia mostly dia bagi macam tu.
Dia reaction between
CH3 and H2 dengan
sama
HNO3.
HNO3.
Lepas tu dia dapat produk CH.
Dia produk dia jadi
CH3OH plus H2O plus N2. Dia jadi 3.
Plus H2O plus
N2. Hydrogen. Jadi 3.
Ini tengok dekat mana? Dia tengok dekat, tengok dekat orang tanya-tanya soalan Quora tu ke, ataupun daripada lecture note other universities ke, macam mana? Tu pun awak kena find out juga macam mana at the end dia come out with this one kan. Dia punya reliability of the source itself. Dapat dari mana?
Saya tengok kat Google and then mostly semua dia bagi macam tu.
Dia boleh bagi macam
Ada
ni?
few dekat website tu mostly dia bagi macam tu. Ada 3 produk. Ke dia macam jenis equation lain madam?
Itulah nak tahu dia punya condition dia tu kan. Tapi sebenarnya dia punya further reaction tu in water. Okay, in water, further reaction tu kita I don't have that much of information lah related to that. Saya as of now saya aware that dia akan produce this salt. Okay, tapi dia punya pecah tiba-tiba dia pecah kepada CH3OH, H2O and nitrogen ni ni kita kena dig in detail lah. Maksudnya macam mana dia produce kan. Tapi not to worry. Okay, sebab kita punya syllabus kita don't go for this one sebab our focus is to determine the pH of the salt kan. Okay, even though walaupun saya tak cakap betul even though dia ada that possibility to somehow this species dia pecah into 3. Okay, bila dia break down into 3 ada je possibility tu. Maksudnya initially dia jadi sekejap and then dia jadi sekejap due to instability dia break into few species. Boleh ada that possibility. Okay, cuma for this reaction saya tak boleh cakap lebih-lebih lah sebab saya kena check juga dia punya condition, okay, dia punya stability and what not. Tapi if we were to base on our syllabus, okay, the focus is more on the salt. Kalau macam ni kita tak tahu salt dia mana. This is alcohol. Okay, this is water. Nitrogen is a gas. Okay, so kita tak boleh nak identify the salt. pH at equivalent point, kita tahu is the pH of the salt. Okay, so let's just focus on di satu ni lah. Kita jadikan yang tadi, like I said, NH3 tadi, HCl, ni yang paling simple kan. It will produce NH4Cl. Okay, so kita stick to that first. Macam kadang-kadang memang equation ni kadang-kadang dia banyak consideration yang kita kena consider lah. Dia punya stability of the compound kan. Sometimes dia boleh terus break. Okay, at instant maksudnya. Dia tak stable in this form. Like I've mentioned to you the H3O+. Okay, kan selalu kita imagine H plus tambah HCl dissociated into H plus dengan Cl minus. Betul, dia dissociate jadi H plus. Okay, if we are based on the HCl. Tapi don't forget that H plus is unstable. So bila dia dengan water, they tend to react with water. So those kind of thing yang may affect the final condition of the compound produce. So that's why ada banyak consideration yang kita kena consider lah. Especially when we are talking about reaction. Okay, tambah pula dia complicated kan. Lagi pula. Okay, so this is the equation. Bila ada nitrogen ni kena careful so kadang-kadang dia hanya produce satu saja produk instead of 2. Okay, alright. So kita nak kena consider the mole. Okay, kita tak pakai concentration because this is reaction. Kita nak tahu is between the acid and base. So to represent the actual, beria madam, to represent the actual reaction between the acid and base, okay, the best way is to use mole. Okay, kita tak guna concentration kerana concentration berubah because concentration dia subject to volume. When the volume change, of course the concentration will change kan, because concentration or molarity is equal to mole over volume. When the volume change, the concentration, the molarity will change. Okay, so we need something that is fixed. I mean, bila dia react tu, it represent the molecules well. Apa dia? Mole. Okay, tapi later, sebab you nak cari pH kan, you nak cari pH is equal to negative log, it should be in concentration, mesti in concentration. But this is not a problem because kita just need the total volume nanti yang kita perlu over kan. Sebab kita nak concentration. Okay, so ni tak apa. Okay, so first step there to find the mole. Okay, alright, so we need to find the mole of any of these two. Because why? At equivalent point, the mole for acid and base should be the same. So once kita dapat satu saja, kita akan automatically know for the other. Okay, sebab at equivalent point. Okay, so we can calculate the mole of siapa yang ada information dekat sini. Okay, for this one, for the weak base lah, because we have the volume and also the molarity. Okay, so let's just put initial mole lah, initial mole. Okay, initial mole. Okay, let's just calculate for weak base because for HNO3 we don't have the information on the volume. We only have the information for the volume for the weak base. Okay, right. So 20 mil. Okay, 0.115 molar. Molarity is also equal to mole per liter. Okay, alright. So what we want is a mole later on kan. So mole per liter tu saya terus je suka sebab this is 1 liter kan. 1000 mil. Kenapa nak perlu buat 1000 mil? Sebab saya nak tallykan dengan this one. Okay, it's either you change this one into mil ataupun you change this one into liter. Okay, sebab at the end of the day it will be cancelled out. Yang kita nak adalah mole. So 0.115 mole. See, mil. Siapa yang pakai dimensional analysis mungkin dah pro, dah boleh main-main guys tu. 1 liter is also equal to 1000 mil, betul tak? So you tekan calculator, you akan dapat 2.3 if I'm not mistaken times 10 to the power of negative 3. Betul tak? Betul tak guys? Betul ke tak? Betul?
Betul madam.
Alright. Okay, thank you. So once you have this one, sebab at equivalent point, automatically this one will be the same. Tu yang tak susah tu, sebab equivalent point. Okay, alright. Initially, of course, there's no product form yet. Okay, after a while, there will be change. Okay, change tu berapa banyak dia change. So dia akan dia will be totally neutralized by one another kan. So dia akan fully neutralized lah. Ini akan dineutralizekan oleh base, oleh acid. Ini pun akan berkurang sebanyak dia juga, which is dia being neutralized with the weak base. Okay, so ini akan bertambah sebanyak acid ataupun base yang present. Okay, so for the final, you akan ada ni 0 because totally neutralized. This is also 0. This one will be 2.3 times 10 to the power of negative 3 mole. Okay, alright. So, okay, so now since we only have the garam, the salt, yang ni yang kita akan carry forward. Okay, so basically this garam is formed between these two acid and base. Okay, that means next step will be the salt dissociation and salt hydrolysis. At equivalent point memang kita pakai salt hydrolysis. Okay, so first step before we go for salt hydrolysis, we have to have the salt dissociation. Okay, so nak ada salt hydrolysis betul, nak ada salt dissociation and salt hydrolysis later on kan. Alright, so first thing first, kita kena ada the concentration of the salt. Okay, so this is the mole only guys. Okay, ini mole, kena aware ini mole, bukan concentration. What we want is the concentration. Okay, sebab kita nak masuk dalam salt dissociation nanti and salt hydrolysis. Okay, so let's find out the concentration of the salt. Okay, the new concentration of the salt, because you know both solution initially they have different volume, and then when they are added in the same container, of course the volume will change. Okay, Alright, so we have to consider for the total volume. Okay, so to find the concentration of the salt, okay, it will be the mole of the salt yang kita dah cari just now over the V total. Okay, so we know that the V total is equal to V of acid plus V of base, and it should be in liter lah. Okay, it should be in liter. Alright, so the mole of salt is 2.3 times 10 to the power of -3. The V of base we have it already. Okay, we have, this is the volume for base. Volume for base berapa? 20 mil. Okay, plus kita sangkut. Alamak, volume base dah settle. Volume acid kita tak ada that information, betul tak? But can we find the volume of the acid? Even though it's not given to us, can we find it? Yes, the answer will be yes lah. Okay, kalau tak boleh nak selesai lah masalah ni kan. Alright, to find the V of acid, the V of acid, kita kena keluar sikit daripada kita tengah sedap-sedap buat ni kan. Alamak, sangkut acid tak ada, kena keluar kejap. Okay, keluar kejap, pergi dekat kali lain, kita boleh pakai the MAVA over MBVB is equal to A over B. Alright, so since we have the equation just now, it is a 1-to-1 ratio. Okay, the molarity of acid, we do have it in the question. Molarity of base, yes. Okay, we do have it. VB also kita ada, only this one can be that need to be determined. So everything is there. So kita pun carilah. Okay, alright. So masukkan all the data. Okay, so you akan dapat VA. Masukkan data daripada tu. Berapa dia punya V dia? 20 times 20 times 0.115. Okay, divided by 0.1014. Tengok betul-betul value tu dia tu jangan 1041. Dalam test banyak tersalah tulis, tersalah tulis. Bukan dia tak reti calculate, dia tersalah tulis. It is 22.68. Betul tak? Okay, times 10 to the power of -3. Why? Because it need to be in liter, guys. Be careful, okay? Sebab you tak tukar mililiter kepada liter je, then the rest are all wrong. Be careful, berhati-hati. Okay, 10 kuasa -3, you have to, this is in mil kan, you convert into liter. Okay, alright, so dapatlah the value 20 plus 22.68 divided by 1000 and 2.3 exponent -3 divided by answer is equal to 0.0539. This is in concentration already, molarity. Okay, you dah ada this one. Sama tak dapat dengan saya? Okay, this is only the concentration of the, sama tak? Dapat tak sama dengan saya? Belum siap lagi Ini kita baru satu second step lah. Did you guys get the same value as mine?
Sama. Ya, madam.
Sama
Sama.
Sama. Okay, kat sini part ni Okay. Okay, so since we don't have enough space dekat sini, obviously, okay, so saya akan pergi kepada slide answer lah. Slide answer, slide answer, okay. Alright, so next sepatutnya, okay, so since we have this value, kita akan buat salt dissociation. Okay, salt dissociation. So salt dissociation, we have this one. Dia punya chemical formula of the salt itself, CH3NH3NO3. Okay, dissociates. See? Satu arah saja sebab this is salt dissociation. Okay, satu arah saja, forward direction. It will be dissociated into its anion and cation. Plus. Okay? Kalau confused, jadikan yang tadi saya cakap NH3 plus NH3 plus HCl tadi. Plus, this will be the cation. See? Okay, so it will be dissociated into these ions. So next we have to choose which of these two ions will undergo hydrolysis. Okay, will undergo hydrolysis. So this one will not be hydrolyzed because why? Dia datang daripada strong acid. That means this is the conjugate base of the strong acid. So it is a very, very weak conjugate base. It will not be combined with water. It will not react with water. But this one will be hydrolyzed. Okay. Alright. So since you tahu ini, okay, kita nak tahu this one 0.0539 kan initially. Since they fully dissociated, initially dia 0.0539 molar. Okay. Once they fully dissociated, okay, dia ni akan habis. So dia akan produce this one. 539 molar. And the same as this one, NO3. Tapi kita tak guna pun this one. Okay, so we need this value only. So ini yang kita akan carry forward. Mungkin saya boleh pakai ke atas lah. No. This one. Okay, boleh pakai ke atas ni. I give you the idea of it lah kan. Hai. Okay, alright. Okay, so kita carry forward this one. Bawa naik ke atas yang salt dissociation yang kat bawah ni. Kita bawa naik atas. We salt hydrolysis. Kita bawa yang this one tadi. CH3 and H3 plus. Okay. Ini yang very, very important part ni. Remember awal tadi kita predict that it will be acidic. Betul? Yeah, it will be acidic. Kita predict dia acidic kan. So maksudnya bila hydrolysis mesti ada water. Okay, ini reversible. This is reversible reversible. That means you have to have arrow that forward and also reverse. You predict the acidic kan, so siap-siap letak H3O plus lah. To make sure that you akan calculate for H3O plus directly. You bukan buat OH minus. Okay, alright. Dah predict dah tadi acidic. Okay, so ni macam mana nak come out with the chemical formula of this one. Kalau obviously H2O accepts one proton from this one. So ni akan hilang kan. Betul tak? Dia akan hilang one proton to H2O. So ni awal-awal dia ada plus kan. So dia akan jadi neutral lah. Hilang proton ni kan. See? Jadi begini. Dia neutral lah. Plus becoming zero charge. Okay? Alright. Okay, so you carry sajalah. This is ice. Kenapa kita panggil ice? Tadi bukan ice. Ini bukan ice ya. Sebab ini panggil initial final table. Sebab apa? Dia punya arrow ni satu direction saja. Ice is only for reversible reaction. Sebab dia ada equilibrium. Okay? Alright. This is just to nak bagi nampak everything lah. So kita dah calculate kan tadi dia punya concentration berapa? This one yang kat bawah ni. 0.0539. 0.0539. Tak ada initial. So after a while, okay, it will dissociated sebanyak X. It will decrease sebanyak X value. Okay, alright, ni pun tak perlu. This one will increase sebanyak X value because dia kebetulan semuanya 1-to-1 ratio. Please make sure of that. Okay guys, plus X. Okay, ini you buat macam biasa je. This is just to have ice table and then to have equation there. Okay, alright. So dekat sini you boleh pakai terus the alternative method. Okay, tahu dah nak pakai color apa. Nak pakai color apa lagi ni? Hitam lah. Saya pakai color hitam Saya buat dekat cenonek dekat sini. Sini kot. Dekat checkpoint atas Alright, so you have H3O plus kan? That means you will be needing Ka. Bila you H3O plus, okay, your final product is H2O plus. That means you will need Ka, not Kb. But what is given to you is the Kb of this quick base. Okay, you tak nak Kb. Okay, so bila you start dekat sini, Oh, aku nak KA tapi dia bagi KB. You pergi cari dulu KA. So, KA times KB is equal to KW. Okay, alright. So, KA, this is the one that we need to find. KB is given, KW is a constant. So, you akan dapat KA is equal to KB berapa? KW 1.0 times 10 to the power of negative 14 over 4.4 times 10 to the power of negative 4. Okay, you dapat the value. Berapa value dia? Ni kalau dah cari tu show pula nak cari kan. Semua nak cari. Exponent negative 14 divided by 4.4 exponent negative 4. 2.273 times 10 to the power of berapa? 11. Okay, so this is the KA. So once you have the KA, tak tahulah nak buat kat mana dah. Saya buat kat sini kat sini selit sini Alright, bolehlah masuk dalam H3O plus is equal to KA times C. Okay, alright, so you have the KA dah cari just now. C, how about C? This one? C is the initial concentration, so you can insert and then you square root everything. Okay, you find out the H2O plus. That will be the concentration of H2O plus. But don't forget, you have to calculate the pH. And then you have to negative log the concentration to get the final pH. Okay? Yeah, itulah plannya. Itulah dia punya step by step process. Okay, alright, so let's look at the slide. Okay, so kalau slide, step 1 dia adalah to calculate the mole. Tapi kalau step saya yang first tadi lebih kurang lah. Okay, kita ada the equation first. And then from there, kita calculate the mole. Okay, alright, so kita calculate, you have to have this equation. So you calculate mole, you masuk dalam the table, the initial final table. Okay, and this one, you akan dapat you kena cari the total volume. So dia tak tunjuk, tiba-tiba dia dah dapat. Okay, sebenarnya guna MAVA over MBVB is equal to A over B. Baru you dapat this one. And then you total up, you insert into this so that you can calculate the final concentration of the salt. Okay, next. You kena calculate the Ka. Okay, so this is salt dissociation. Okay, alright, so this will not be carried further for hydrolysis, but this one will. Okay, so bila you buat dekat sini, you notice that you will produce H2O plus. You kena produce H2O plus sebab kita dah determine, dah predict awal-awal tadi kan. So bila H2O plus, you need the Ka. So bila you kena Ka, you baru cari Ka dekat sini. Kalau saya cari Ka kat bawah ni lah. Okay, sebab H2O plus Ka. Okay, alright, and then from there, see, nampak tak? Bila you dah ada ice table, okay, you still can use ice table even though you are using the alternative method. Ni pakai alternative method ni. Okay, masukkan, you dapat the final value. Okay guys, alright. Okay, alright, so that is all for the checkpoint. Any questions so far before we proceed to acid-base titration curve and indicators, the indicators? Ada soalan?
Tak ada, madam, clear.
Okay. How about the rest?
Clear, madam.
Okay.
No, madam.
Okay, right, so janganlah salah the equivalent point. Okay, so dah quite obvious dah step by step process dia tu. So tolong jangan salah lah, because kat situ normally equivalent point we carries 5 mark kalau dia tanya determine the pH at equivalent point. As you can see the steps are plenty lah, maksudnya banyak, quite dia requires a quite number of steps to finally produce the pH at equivalent point. Okay, tapi it's predictable lah kan, pH at equivalent point. Okay, alright, moving on to indicators. pH indicators. What is indicator? Okay, so in an acid it is an acid-base indicator. Okay, this acid-base indicator is a weak organic acid. Okay, so it's actually a weak organic acid or a dye, okay, whose color differ from that of its conjugate base. So like maybe you are familiar with phenolphthalein, thymol blue, okay, litmus, okay. So these indicators are actually acid sebenarnya, weak acid. Bila dia weak acid, it will produce, when it dissociates, it produce conjugate base. Weak acid dissociate, producing conjugate base. So to represent organic acid, okay, we have H. It shows that it carries hydrogen. IN stand for indicators. Okay, alright. When they dissociate, they akan produce the conjugate base, IN minus, indicators minus the anion lah. Okay. Alright, so and the thing about this weak organic acid, what's so special about it is it has color. Dia ada color. Okay, dia ada color dekat situ. So dia bukan base tau, dia adalah weak acid yang digunakan sebagai indicator. Indicator means to indicate something. Okay, to indicate that we have to stop the titration, to indicate that the equivalent point has been reached. It's an indicator to indicate something. Okay, alright. So many dyes change color depending on the pH of the solution. So a lot of dyes, okay, the reason it is used as indicator because it change color. Okay, they have the ability to change color depending on the pH of the solution. That is very interesting about indicator ataupun this type of organic acid lah, weak organic acid. Okay, tak semua organic acid tu adalah indicator, tapi kebanyakannya dia datang daripada organic acid. Okay, alright. So for most titration, the titration curve shows a very large change in pH for very small addition of titrant near the equivalent point. Okay, alright. Because we know that equivalent point is very specific. That means at this equivalent point, the mole of acid should be the same as the mole of base, not one bit, okay, atau less ataupun more than the other. Dia kena exactly the same. Kalau to you, one drop is actually small, sebenarnya one drop tu carry berapa mole? Because dia kena exactly sama, dia tak boleh lebih pun sikit pun. 0.001 mole pun tak boleh lebih. It should be exactly the same. Okay, equivalent point. Maksudnya dia kalau 8.72, so it should be 8.72. Macam itulah nak imaginekan dia. So to you, that one drop, it might be very small. Tapi sebenarnya, we cannot just based on, dia satu drop. Satu drop je mana? Satu drop, bukan 1 mil. Bukan based on that. So you have to consider in terms of the amount of titrant that they carries ataupun the amount of molecule ataupun mole of the titrant yang dia dalam satu drop. Okay, so that's why kadang-kadang bila kita drop kan, satu titik dia, color dia tu berubah jadi pekat. Sebab it is already exceeding the mole sepatutnya dia kena sama, dah dia terlebih dah. Okay, that's why dia cakap the titration curve shows a very large change in pH for very small addition of titrant near the equivalent point. Remember kalau kita buat dia punya pH curve kan? Kalau saya buat gini suddenly macam tu. The equivalent point katakanlah is around here. Okay, so dekat sini katakanlah kan, you baru letak dekat situ, dekat kawasan ni kan, tiba-tiba you letak satu drop, terus baru you letak satu drop and then suddenly katakanlah this is around 2 or 3 something lah. Okay, you letak 3 point, dia increase kan 3 point, maybe 3.6, 3.7, 3.8 and then suddenly you add in just one drop of the titrant. Then the pH goes up drastically. Okay, that one drop dia terus jadi Katakanlah 10. Okay. Katakanlah 10. So from 3 to 10, just by that one drop saja. So itulah maksudnya shows a very large change in pH for very small addition. Baru tak satu drop tapi dia punya change in pH is very drastic because it's already near the equivalent point. But how near is near? Tu yang kita kena extra careful lah, especially bila dia dah colour tu dia dah tukar colour and then tapi dia come back to the original colour. That is the indication on dia indicates that it's already nearing the equivalent point. You pernah buat titration tak masa SPM? So unfortunately kita tak ada eksperimen, the physical experiment kan as of now. Tapi kalau yang dah buat virtual experiment, okay, dah eksperimen 3, eksperimen acid and base, okay, dalam video tu dia akan tunjuk the colour starts to change tapi dia come back to original colour. Maksudnya apa? Menunjukkan dia dah nearing the equivalent point. So you kena be careful guys tu. Instead of you have to drop 1 mil, maybe you have to reduce to 0.5 mil, 0.1 mil. Okay, sebab dia dah nearing the equivalent point. Because kalau dia dah change colour to permanent pink, that means dia dah exit dah already. Because pink, usually for phenolphthalein, it represent basic. Dia dah base sebab kalau dah base maksudnya dalam reaction tu dah colour pink, maksudnya dah ada base berlebihan di situ. Okay, so maksudnya at equivalent point dia sepatutnya colourless sebenarnya. Okay, ataupun kalau kita nak stop the reaction, it should be very very pale pink. Pale tau, macam pucat tapi dia permanent, dia tak berubah dah colour kepada what do you call it, kepada colourless tu. Okay, tapi student nak lagi pink. Lagi pink, lagi cantik. Bukan macam tu so dah belajar kan. So you kena apply. Bukan nak colour pink lagi dark pink tu lagi you suka. Bukan macam tu. Pink tu maksudnya dah menunjukkan dia basic. Okay, so an indicator can therefore be used to determine the end point of the titration. Okay, but as you know, the indicator is based on colour. So the colour may varies. Okay, boleh berubah depending on the viewer. So tak, saya nampak pink, yang kawan lagi seorang tak nampak pink lagi. So itu dah ada error dekat situ. So that's why it is used to predict. Okay, it is used to predict the predict the equivalent point. Tak, dia beritahu kita that it is nearing the equivalent point. Macam tu. Dia tak boleh beritahu kita the accurate pH at equivalent point. Tak, sebab dia based on colour. Colour may varies. Okay, so this is what we call end point. Maksudnya let us know that okay, we are nearing the equivalent point. And then once dia dah permanent colour, the change colour and then permanent, so it's already end point. So we should stop. Okay, and we should stop titrating now if you are going for equivalent point. Tapi kalau you nak main-main titrate tu, go ahead lah. End point adalah di mana the colour of the indicator change. Okay, itu end point. End game. Okay, so as you know, we have a lot of indicators. So how do we choose which indicators are suitable with our acid-base titration? Kita ada banyak acid-base kan? So kita nak pilih the best indicator for our acid-base titration. So how do we choose? How do we select our indicator? Tips number 1. Okay, we are going to be based on the pKa of the indicator. Kenapa pKa? Because the indicator is a weak acid. That's why bila dia weak acid, dia ada Ka, and we can also calculate the pKa. Okay, so we are going to be based on the pKa of the indicator, and we should know the pH at equivalent point. Okay, for that acid and base. Okay, so the pKa should be almost the same as the pH that we are looking for. pH at equivalent point for the acid and base that we are looking for. Okay, dia kena lebih kurang sama. Dia pun kata lebih kurang sama kan. Kalau exactly the same, even better. Tapi kalau tak dapat sama, lebih kurang sama pun consider okay. Okay, tips number 1. pKa is equal to pH at equivalent point. pH of the acid and base itulah. Okay, and then secondly, we have to make sure that the equivalent, the indicator tu, it changes color within the same range as the rapid change in pH. Okay, so maksudnya kita kena make sure that the indicator tu dia kena change color, apa nama tu, di kawasan yang nak dekat-dekat, apa nama tu? Nak dekat-dekat equivalent point. Contohnya, this one is the equivalent point kan? This is the equivalent point. So as the rapid change in pH dekat kawasan ni, this is the steepest portion kan? Normally dekat sini. So you kena make sure that dia punya pH dia kat mana ni? 3 point something to 10. Itu range dia. As long as dia dalam range tu, okay, kita consider dia in the range. Dia kena change color around this, at this region lah. Janganlah kita nak dia, katakanlah this is like 8 kan. Tapi dia dah change color at 4. Okay. The indicator change color pada pH sama dengan 4. Dah tukar color. Tak nak lah macam tu. Okay, itu maksudnya the indicator use is not suitable. So you kena pilih the indicators that changes color, okay, see the within the same range as the rapid change, dekat steepest portion ni, as long as di dalam this steepest portion, okay, and it also cover the pH at equivalent point. Okay, so these are the indicators. Yang paling famous sekali will be the phenolphthalein lah. Okay, you see, even the phenolphthalein, okay, the change in color, the range of pH change is 8.2 to 10. So katakanlah you nak buat reaction antara HCl dengan sodium hydroxide. So you tahu the pH at equivalent point will be 7 because both of them are strong acid and strong base. 7. So this is considered as out of range. Kan? pH at equivalent point 7, tapi ni dah tak termasuk dalam range dia, betul tak? So sebenarnya ada lebih better indicators that can be used other than phenolphthalein sebenarnya, but that's one thing yang you kena tahu juga, nak share lah benda ni kan. Phenolphthalein, why is it so famous? Because dia murah. Okay, murah, dia stable, easy to prepare. So these are the consideration that we have to take into consideration lah. Okay, kita kena bear in mind for this factor juga. Ada indicator juga, ada indicator yang they are very hard to prepare, and then expensive, and then unstable. Unstable, that means it need to be prepared freshly ataupun it is easily oxidized, those kind of thing. Okay, so benda-benda macam tu menyebabkan dia susah untuk di-prepare. Okay, compared to phenolphthalein. So that's why sometimes even though kita punya pH at equivalent point is 7, we still use phenolphthalein. Okay, it depends on apa yang kita nak lah from that reaction. Sometimes kita just nak tahu, okay, aku dah kena stop dekat this. Once it changes color to pink, stop. Ada orang buat reaction macam tu. Ada orang nak tahu exactly. If you want to know exactly using the indicator, that means you have to choose other indicator other than phenolphthalein. Okay, alright. So here we have quite a number of indicators that can be used. Okay, as you can see, we have the range. Range ni maksudnya the color will change. Okay, the indicator will change color from yellow to blue. Tapi bila dia change color? Okay, bila dia change color. So dia change color maksudnya 0.2, 1.8. Maksudnya dia akan change color. Yellow means acid, blue means base. Okay, dia akan change color to from this dalam this range lah. Okay, so below 0.2 dia yellow, above 1.8 it will be blue. Tapi kalau PHU 7 for example kan, you nak dekat-dekat dengan 7 tu baru you nak stop reaction, tapi ni dah tukar color. Okay, so ni tak sesuai lah. Ni dah awal-awal dah tukar color. Belum sampai equivalent point, dah tukar color dah. We don't want this. This is not suitable. That means this indicator is not suitable. Same goes to this one, not suitable, not suitable. Okay, bukan nampak indikator dia pakai. No, you kena identify juga. And then one more thing, you kena consider pKa is equal to pH at equivalent point. Satu lagi, you kena make sure dia dalam range. Okay. Right, cuba buat checkpoint 14. We have question 1, 2 and 3. Okay, try to do it. I give you like maybe 4 minutes. Sengaja tak nak 5 4 minutes for you to complete this one. Okay, bukan kena calculate pun. Just tengok and then pilih the indicators that are suitable to be used for the reaction. Cuba. Okay, right. So are you done, guys?
Dah.
Okay. Right, how about others? Are you guys done? The rest?
Yes, madam.
Yes, madam.
Yes, madam.
Okay, thank you. Alright, so let's discuss the answer. Okay, graph below shows the reaction between KOH and HNO3. Choose one suitable indicator with the color changes that can be used in this titration. So this is the equivalent point as shown in the data. So we have 7. pH at equivalent point is equal to 7. So cari yang dalam range ini. Mana-manalah dapat kat sini yang besar ni ke ataupun yang ini ke. Yang dia mesti cover that equivalent point and then they are at this region, at this steepest portion. Okay, yang manakah yang sesuai. So obviously kat sini kita nak 7 kan, ini tak boleh. Ini dia tak masuk range pun. Ni pun tak boleh, ni tak boleh. This one tak boleh sebab dia tak sampai lagi kan 6.8. Dia tak reach 7. So this one suitable. This is also suitable. Litmus also suitable. This is ini dah border kan. Okay, sebab dia dah atas the equivalent point. This one dah out of range dekat situ. Okay, alright. So these are the possible indicators that can be used with subject to this strong acid versus strong base. Okay, alright. Question number 2. Between sodium hydroxide and weak acid. So the pH would be more than 7 lah kan. Okay, kalau from the data it is 8.72. Okay, so cari range yang dekat kawasan yang cover the equivalent point and this steepest portion lah. Dekat kawasan ni pun boleh. Tapi yang steepest tu lah. Okay, alright. So what are the possible indicators? Is cresol rate and phenolphthalein. Okay. Okay, question 2. This is question 3. NH3 dengan H2SO4. So strong acid versus NH3 weak base. So it will be slightly acidic. Nampak tak data dia? 5.28. Okay, so make sure it's in the range of the indicators. So what are the possible indicators? So these are all the possible indicators that can be used. Okay. Alright, okay, done. Moving on to next, the last subtopic for topic 3, the buffer solution. Okay, alright, so maybe we can take a break like 3 minutes. Sengaja madam tak nak bagi 5 minit 3 minutes. Okay, for a break, and we will continue at 3:18. Okay, we will come back at 3:18. Okay guys, pergi tarik nafas selama 3 minit tu. Okay, alright, see you. Okay, so let's get back to business. Okay. All right. Buffer solution. So these are the learning objective that you should know. Okay, so we have 1, 2, 3, 4, 5, 5 of them. Make sure that you cover all of them. Okay. All right. Okay, so before we proceed further, we have to know the definition of buffer. So what is buffer? Okay, so how do we define buffer? So a buffer solution is a solution of weak conjugate acid-base pair. That means it has the weak acid or weak base and also the conjugate. Okay, all right. That means, that means in the buffer we have to have two components. Okay, that are compulsory. Okay, so these two components must be present. The first component is either weak acid or weak base. The weak one lah, yang weak bukan strong lah, dia bukan strong acid, bukan strong base. It should be weak acid or a weak base. Either one. Ini salah satu. And secondly, the second species ataupun the second substance that need to be in the buffer is its salt. Garam kepada weak acid ataupun garam kepada the weak base. So these two are compulsory to be present in buffer. Okay, dia tak boleh strong acid dengan salt, dia tak boleh strong base dengan salt, tak boleh yang strong dengan salt, tak boleh. It should be the weak and the salt. Okay, alright, so the buffer can be divided into two. So we have two types of buffer, acidic buffer and basic buffer. So it is obvious, okay, from the name, the type of the buffer itself, acidic buffer, that means it should be a mixture of weak acid and the conjugate and its conjugate base. Okay, so this conjugate base, kalau in general, we can also call it as salt lah, salt. Okay, macam ni kan. Okay, for example, CH3COOH is the weak acid. Okay, and then we also have the conjugate base. This is the conjugate base. Kalau normally kan, this one, salt dia adalah yang kita familiar would be this one, sodium acetate, betul tak? So this is the salt. Tapi yang sebenarnya yang kita akan gunakan adalah the conjugate. This is the conjugate base of the salt. Okay, conjugate base dia asal daripada salt, tapi ini saltnya bila kita dissociatekan the salt, we will produce this conjugate base. Okay, and this conjugate base ataupun salt must be related to the acid. Dia janganlah acetic acid tiba-tiba ini NH4+. Tu kan tak ada kena-mengena. Kan? Dia mesti ada interrelation between the acid and the salt, the conjugate. Okay? Okay, and then basic buffer is a mixture of weak base and its conjugate acid ataupun dia punya salt dia lah. Okay, alright, so this is the weak base and this is the conjugate acid. Dia punya pairing dia. Normally yang kalau kita familiar NH4+ ni normally NH4Cl, okay, NH4NO3, tapi bila dia dissociate it will produce NH4+. This is the conjugate acid of the weak base. Okay, so the name is apa nama tu? It can be used interchangeably. Maksudnya dia boleh digunakan to represent the buffer. Sometimes you can use conjugate, sometimes you can use salt. Okay, tapi you kena tahu dua-dua ni apa beza dia. Kalau salt maksudnya the salt itself. Tapi kalau conjugate it is more specific. Okay. So how do we form buffer solution? Very simple. Okay, we need to have these two components. If we want to prepare the acidic buffer, okay, we can just simply add the weak acid, combine the weak acid and the conjugate base of the weak acid. Okay, so kita tambahkan dua in one beaker. So there you go, your buffer solution. Okay, so a buffer system can be represented as salt acid or conjugate base acid. Okay, conjugate base, dia ada acid and base at the same time. Cuma base dia tu datang daripada its conjugate. Okay, all right. So we can represent the buffer as this, okay, or alternatively as this one. So the salt and the weak, the conjugate base and the weak acid. Okay, boleh guna dua-dua So this is a basic buffer. Okay, basic buffer, that means we have the weak base combined with the conjugate acid ataupun the salt. Okay, you will produce a basic buffer solution. Okay, all right. So you can, this is example that we have here is ammonia and NH4Cl. So you can name the buffer as this, the basic buffer as this, the salt and the weak base, ataupun the conjugate acid and the weak base. The weak base wajib lah, memang kena ada. The weak must be there. Okay, cuma kita nak namakan dia the salt tu dalam bentuk conjugate ataupun we can also name it as salt. Okay. Application of buffer. So buffer is very important. Buffer has so many applications. Okay, one of it would be in our body. Okay, we have buffer in our blood. Okay, so blood behave as a buffer. Okay, so a buffer of carbonic acid and hydrogen carbonate. Okay, keep the pH of the bloodstream at a neutral 7.4 as any deviation from the human blood pH of 7.35 to 7.45. Maksudnya this will be the range. You guys see the basal is only 0.1. Okay, if somehow the blood is out of range, the pH is out of range, it can have extremely disruptive effect. It will be very, very dangerous, guys. Okay, so that's kita punya blood has is also known as buffer. Dia ada ability to maintain the pH. Okay, it has the ability to maintain the pH. So boleh baca in detail. Okay, how does the blood in our body behave as buffer? Okay, so paling common yang kita selalu dengar adalah carbon monoxide kan. If we stay too long in the car and then the car has problem, air conditioning punya problem, dia leaking ke somehow kan, so carbon dioxide will be produced, and then when we inhale this carbon monoxide, okay, the thing about carbon monoxide ni, dia has higher tendency to bind with the hemoglobin in blood kan, in dalam darah kita kan. Dia kalau oksigen dengan carbon monoxide lebih hemoglobin tend to bind faster with the what do we call that, carbon monoxide. Okay, dekat situ, bila dekat situ kita dah lack of oxygen dah dekat situ, oxygen dah kurang dekat situ, which is detrimental to the body. Okay, and then one more thing, dia dah jadi and then acidic kan. So carbon monoxide, when it is dissolved in our bloodstream, it will produce an acidic condition dekat situ. So that also cause the pH to be the pH of the blood to be out of range. Okay, so that's why they're very, very dangerous. When kalaupun you survive from the ni, mesti ada defect lain pada you punya body. So please be careful. Okay, kena check, especially kereta-kereta lama tu, takut ada leaking. Okay, pesanan penaja. Okay, and the buffer with the human body is the hemoglobin complex. It's related to hemoglobin lah. Okay, the binding effect dekat situ, which bind to excess proton, H+ ion muscles released during exercise so that the body can use the oxygen. And one more thing, okay, related to exercise, when we exercise, we tend to breathe faster kan, so and we tend to produce more carbon dioxide. So how the body adapt to that? Okay, so it's very interesting. Okay, you may dig in this apa nama tu related to this application of buffer yang ada kena-mengena dengan kita punya blood lah. Okay, this is not bio, dia ada kena-mengena dengan chemistry juga dalam ni. Okay, so you can further read apa nama tu related to the subject matter just now. Okay, application of buffer. Okay, buffer is also used as can be commercialized, okay, into products. So the most common one will be shampoo, baby lotion, kan? Shampoo contains buffer of citric acid and sodium hydroxide, example, which work to balance out the natural alkalinity of soap. Okay, so then baby lotion is buffered to a slightly acidic pH of 6, which inhibit the growth of bacteria and other pathogens. Okay, so not all neutral will be the best pH lah. It depends on the condition, depends on the situation. Tak semestinya neutral tu bagus saja. Okay, so dia depends. Macam kulit kita is slightly acidic kan. Kulit muka kan, dia kulit kita dia slightly acidic. Sebab apa? It has the ability to protect. It has a layer of protection dekat situ to protect from bacteria or other pathogens. Okay, so kalau dia neutral, dia tak ada protection dekat situ. Okay, dia tak ada protection and then it easily attacked by the pathogen ataupun bacteria dekat situ. Okay, so that's why dia acidic. So ada bacteria-bacteria yang mild and very light kan, dia tak boleh stand our skin. So that is how skin, okay, dia punya dia punya tanggungjawab kulit kepada kita lah. So you kena tahu condition, situation, bila nak guna, apa dia, and then use the right product. Okay. Okay, checkpoint 15, question 1, choose the mixture that yields a buffer solution when equal volumes and concentration of the two solutions are mixed. Okay, so baca 15 saat, saya nak jawapan sekarang. Okay, anybody? Okay, jawab This is based on definition that we have learned just now related to buffer. Okay, so which of these followings A, B, C or D produce buffer? Boleh jawab mana-mana, tak kisah. This is based on what you have understood from our previous slides. Nanti baru kita tengok jawapan. Tak apa, bagi je jawapan awak based on what you have understood. Okay, alright, cepat. Come on guys, apa jawapan dia? You punya jawapan apa? Bukan apa jawapan dia, you punya jawapan apa?
B.
B for ball ke B for donkey? Donkey, alright. Okay, how about the rest?
B.
Donkey. Sebut donkey atau ball ataupun ayam ataupun cacing.
Chicken, madam.
Chicken, okay, chicken. Okay, chicken also got. Okay, next lagi. Come on guys.
Donkey.
Six of you. Sorry?
D, madam.
Okay, donkey. Alright, lagi, keep coming. Baru berapa tadi? 6 orang. Berapa?
Madam.
Dadu boleh lagi? Donkey lagi? Okay, tak mau lambat main panggil nama. Jap. Mana ni? Itulah, tak tahulah nak pergi mana. Ni ada kat sini. Oh, ada. Nur Fatin Maisara. Fatin, what's your answer, Fatin? D, donkey. Alright. How about Sharifah? Sharifah Nurul. Tak habis kat sini. Sharifah? Sharifah, are you there? Ni tak nampak lah, tak best. Sekejap sekejap. Saya nak pergi sini. Okay, tadi siapa? Okay, alright. Azri, what's your answer, Azri?
Dengkil.
Dengkil. Haikal, Muhammad Haikal bin Muhammad. Alah, tak nampak sini. Dengkil. Okay, alright. Nafis. Mana Nafis ni? Nafis?
Ya, madam.
Nafis, what's your answer for checkpoint just now? A, B, C or D?
D.
Checkpoint 19, this one. This one. Kita nampak pula kat bawah tu kan. Okay, ni jawab. Jangan based on jawapan tu Jawab sendiri based on apa yang you tak tutup kat sini. Okay. Afiq, Muhammad Afiq. Muhammad Afiq. Sorry? Apa? Come again, Afiq?
Yes. Yes, madam.
What's your answer for this question just now? D, donkey. Alright. Okay, what else? Saya tak cakap betul ke benda lagi kan? Nak tahu based on your understanding. Siapa? Azwa. Nur Azwa Liana. Azwa. D, madam. Okay. Kalau problem mic, respon kat chat Okay. Hafizah binti Sapeli.
D, madam.
D or B? Bola or donkey?
Donkey.
Hai. Alright. Hikmah. Nur Hikmah.
D, madam.
Okay, D also. How about Kristina?
D, madam. Donkey.
Right. Okay. D juga. Maybe last one. Let's have Faris. Boleh juga kita nak tahu you guys ada kat depan laptop ke apa kan, tengah buat apa tu. Siapa tadi saya panggil? Faris Faris. Faris.
Yes, madam.
What's your answer? Faris, tak dengar.
Ya,
Apa? Apa? Donkey ke, ball ke, chicken ke, ayam? Dadu. Okay. Donkey lah. Alright. Okay. Yes. Donkey kan? Betul tak? Donkey. You cakap donkey kan?
Betul.
Alright. Okay. Alright. So, I think that is all. Okay. That's enough for now. Okay. Let's check the answer. The answer will be D, guys. Okay. D. Okay. So, you gonna come back to the definition. Okay. The definition of buffer. Okay. Dia kata choose a mixture that yields a buffer solution. Okay, when equal volumes and concentration of the two solutions are mixed. Bila kita campurkan dua tu lah. Okay, yang mana produce buffer solution. Okay, so HCl. This is strong acid. So the moment we have strong acid and the garam, strong acid is not considered as buffer. So out. How about HClO4? HClO4 is a strong acid also. So this is also out. Okay. And then chicken, our chicken here, KOH. KOH and KCl. KOH is strong base. It's a strong base. So it's bukan weak acid ataupun weak base. So dia salah lah. Okay, yang weak hanyalah HF. So you tak ada masalah kalau you tak hafal lagi your strong acid ataupun strong base. Okay, so HF and the salt ataupun the conjugate dia mestilah related. Tak bolehlah HF dengan NaCl. Tak bolehlah macam tu. Dia kena its conjugate. So we have HF, right? So it should be, the conjugate should be the F minus. Okay, so this is, kalau keluar objektif, 2 markah hilang macam tu je. Sayang tau, 2 markah is either 2 or 0. Macam yang dekat test awak, macam yang dekat final awak nanti, 2 markah untuk objektif. Okay, so be careful. Kalau dekat structured question, still boleh lagi kita consider 2, you can get, sometimes you can get 1, sometimes you can get 1.5, sometimes you can get half. Tapi kalau objektif, sorry, tak boleh buat apa. Okay? Alright, so be careful again. Objektif paling critical. Okay, how buffer works. Okay, how buffer works. This is important. Okay guys, so you have to listen carefully so that you know how, what is the purpose of having buffer lah in the first place. Okay, why do we need buffer? And then how does buffer work? Okay, alright, so let's start with acidic buffer lah. It's actually the same. Kita ada acidic, kita ada basic, but the understanding is still the same. The concept is still the same. Okay, alright, so let's start with acidic buffer. Okay, alright, so this is the reaction lah. Okay, the what do we call that? The equation involved. Okay, so we have the acid, and then at the same time we do have the conjugate base, betul tak? We have the acid and the conjugate base. Tapi apa yang kita buat this equation adalah equation of weak acid dissociation. Betul tak? It's a weak acid dissociation punya equation. See, kita HA in water. This is reversible to produce A minus the anion or the conjugate acid. Is it conjugate base? Sorry, conjugate base. So since this is a weak acid, that's why they produce H2O+. Okay, alright. So what the substance that are present in large amount is the weak acid and the conjugate. Sebab buffer, ingat buffer apa? Buffer kena ada weak dan kena ada conjugate base-nya. Okay, maksudnya these two will be present in significant amount in the buffer solution. Okay, yes, bila acid dia dissociate in water, dia akan produce the same ion. Betul tak? Dia produce the same ion as the salt just now. Tapi dia partially dissociate. It only produce the sikit je dia punya dissociation tu. It's not enough to cover later kita nak masukkan acid ataupun base into the buffer. So that's why kita kena support the system by adding the salt ataupun the conjugate base into the buffer. So that's why we can use this equation to represent the buffer. Kita boleh gunakan equation ni untuk represent buffer. Maksudnya dia ada significant amount of acid, the weak and also the conjugate. Based on definition, bukan saya buat-buat, based on definition, dia ada significant amount of these two ions. Okay, so buffer works by applying Le Chatelier's principle. So we are still going to be using the same principle that we have learned in topic 2. Okay, because why? Because it involves equilibrium, because it involves reversible reaction. Okay, so acidic buffer solution contain, like I said, significant amount of the weak acid molecule. Ini ada banyak. And also this one. Sebab kita tambahkan salt kan. Salt tu akan produce the conjugate base. The conjugate base, yes. Okay, so the purpose of having buffer, of having these two, okay, the weak acid and its conjugate base adalah, okay, to help maintain the pH. Maintain the pH. Tadi kita belajar dalam blood tadi kan, untuk dia maintainkan the pH kan. Okay, now dekat dalam lab, how do we maintain the pH? Okay, bila kita disturb the system. The Chatelier's principle kan, it's all about disturbance. Okay, you have buffer, and then you disturb the system by adding OH minus, by adding base into the system. Okay, you add in base into the system, that means you add in OH minus into the system. So what actually happened is that, bila OH minus is added into a solution, okay, katakanlah OH, sodium hydroxide, is added into water. For example, this is not buffer. Katakanlah kita keluar sikit daripada buffer. Okay, you have water and then you have sodium hydroxide. You add it into water, and then what happened to the pH, guys? The pH will increase drastically. Dia akan increase drastically. Kenapa? Because there is a presence of OH minus in the solution. So pH akan naik secara mendadak sebab ada free OH ion dekat situ. Okay, so we don't want that to happen. So in order to counter the disturbance, the OH minus tu, something need to be done. That means something need to be used in order to neutralize the OH minus. Okay, so let's come back to buffer just now. So in buffer, we have acid, right? So when base is added, OH minus is added into a buffer system, the weak acid from buffer tu akan hantar bala tentera dia to neutralize the OH minus. To neutralize the OH minus added just now. So there is no OH minus available now. So the pH, what happened to the pH? The pH can be maintained. Because there's no free OH minus. The reason it goes up, the pH goes up, is because of there is OH minus in the solution. So since tadi weak acid dah neutralize the OH minus, weak acid from the buffer system tadi dah neutralize the OH minus, so there's no OH minus anymore in the system, in the solution, and therefore the pH can be maintained. Yes, it is true that the pH will increase slightly. Sebab after all, the concentration of weak acid is now decreasing because it has been used to neutralize the OH just now. Betul tak? Dia digunakan. So weak acid punya concentration dah reduce. Bila weak acid punya concentration dah reduce, of course H3O plus pun akan reduce. Betul tak? So the pH will still increase, but it increase slightly ataupun gradually. So the pH can still be maintained dekat situ. Faham? Alright, so how do we write the equation that shows the neutralization of the weak acid in the buffer with the added OH? HA plus OH minus, okay, producing A minus and H2O. Okay, so ini akan diambil oleh OH minus, dia jadi H2O. Nampak? So there is no OH minus available in the solution. Therefore, the pH can be maintained. Okay, kalau you faham yang tu, how about if we, instead of we add in OH minus, kita add in H3O plus. Okay, nah inilah kegunaan buffer. Dia counter attack. Oh, OH mana masuk? Acid dihantar orang serang. Serang as in dia neutralize kan lah. So there's no OH minus available. Okay, alright. Same goes to acid. Okay, so imagine if we have acid added. If you have acid kan, okay, you have water and then you have HCl. You add in HCl into water. So what will happen, guys, to the pH? The pH will go down drastically. Kenapa will go down drastically? Maksudnya pH akan menurun secara mendadak. Why? Because there is a presence of H3O plus in water. Tak ada orang yang boleh neutralizekan the H3O plus. Because we only have water and HCl just now. So bila dia dissolve, dia masuk dalam air, so it produce H2O plus kan. So we have free H2O plus in the solution. So bila ada H2O plus, it cause the pH to decrease drastically, to reduce drastically. Okay, so itulah yang akan berlaku bila H3O plus ataupun acid is added into water. So what if bila acid is added into a buffer system, into a buffer solution? What will happen? Okay, alright. So the buffer solution also contains significant amount of the conjugate base and ion. Okay, like I said just now, ni buffer kita, we have the acid and its conjugate base. So this is acid. This is even though the conjugate base, dia still base guys, dia still base. So ini ada banyak dekat dalam buffer. We have significant amount of weak acid and also conjugate base in the system, in the solution. So apa purpose dia? Okay, weak acid tadi dah cover base ataupun OH minus. So kalau conjugate base ni, dia akan cover acid, H plus ataupun H3O plus. Dia akan neutralize the H3O plus. Okay, alright. So this ion combine with added acid to produce more HA. So what happen is that the A minus, okay, which come from the conjugate base of the buffer tu, will react with the acid added to produce HA and H2O. So the proton from H3O plus, okay, one of the proton will be given to A minus becoming HA and H2O. Takkanlah dia, lagi satu dia mana boleh nak accept lagi satu hydrogen kan? After all, there's no extra hydrogen from A minus. So takkanlah dia jadi H4O pula. Kan? Mestilah jadi H2O. Okay? And there's no, as you can see, there's no H3O plus available. Okay, faham tak macam mana how buffer works? Faham tak fungsi buffer tu, guys? You guys understand? Are you guys following? Do you have problem so far?
Faham, madam.
Faham ya? How about the rest? Faham tak? This is very important, guys. Faham tak?
Madam, boleh ulang sikit tak yang H3O plus tu dia counter attack ke A minus?
Counter attack. Okay, tadi kita OH minus, kita kacau sistem tu by adding OH minus kan. Now, what if you kacau sistem tu, you masukkan acid. Acid lah, you masukkan HCl ke, you kacau sistem tu by adding acid. Acid, dia H plus and then dia combine dengan H3O plus, dia akan combine dengan H2O, dia jadi H3O plus kan. So acid lah, nak menunjukkan acid. Okay, so you add in acid into the buffer solution. So what will happen? Okay, so since dia adalah buffer, dalam buffer solution tu dia akan ada, since we are talking about acidic buffer kan, dia ada weak acid dan dia ada conjugate base dia. So since yang masuk tadi adalah acid, so conjugate base yang maksudnya dalam buffer tu ada base kan, conjugate base tu dia akan counter attack the acid added. So ni dia akan neutralize, this is the acid, this is the base yang memang dalam buffer tu, it will be neutralized with the conjugate base tadi. So dia akan totally neutralize. So masuk lagi neutralize, masuk lagi neutralize. Faham tak? So that's why dia able to, bila the moment dia neutralize, there's no H3O plus lagi yang available. Masuk lagi dia neutralize lagi. So tak ada H3O plus. So that's why pH tidak jatuh mendadak. Dia tidak jatuh secara drastically. Dia turun, ya, dia akan decrease but slightly decreasing. Because there is conjugate base present to counter attack if the strong acid ataupun the acid is added into the buffer solution. Okay, so dua-dua orang ni, weak acid dengan conjugate base ni, dia always in alert mode lah. Maksudnya, okay, siapa yang masuk ni? Acid ke base? Acid masuk. Okay, so base diserang, neutralize kan. Okay, ni kejap lagi, siapa masuk ni? Siapa masuk? Tadi acid ke base? Tadi cakap apa? Base masuk. Base masuk. So yang behave sebagai acid dalam buffer ni akan pergi neutralize that base. Okay, itulah fungsi buffer. Bila dia neutralize kan, so pH tidak akan increase ataupun decrease secara drastically. Faham?
Faham, madam.
Okay, and make sure that you are able to write the equation if you are asked to do so. Okay, alright. So you kena tahulah siapa. Okay, kalau OH masuk, siapa yang akan serang OH tu? Acid. Jangan salah pergi orang lain pula serang. Okay, HA yang akan react with the added base to produce this. Okay, same goes to kalau H3O+. So it will react with what do we call that? What do we call this? Conjugate base. Okay, so diorang ni, dia jadi buffer ni, kenapa kena ada dua komponen ni? Because they both serve purpose dekat situ. Dia ada fungsi dia, bukannya main suka-suka je duduk dalam tu. Okay, duduk dalam ni, duduk je lah tengok. Okay, ada fungsi masing-masing kat situ. Okay, kenapa weak acid tu? Kenapa weak acid kena ada? Kenapa conjugate base kena ada? Okay. Right, moving on. Okay, so this buffer solution, okay, like I said just now, resists significant changes in pH when small amount of acid or base are added to it. Okay, they resist significant changes in pH. Like I said just now, kalau dia adalah water, you masukkan acid dalam water, pH akan jatuh. Maksudnya significant changes in pH. Maksudnya pH akan jatuh secara mendadak. Ataupun you ada base, you masukkan dalam water, pH akan increase secara drastically, significantly. Okay, but since this is buffer has that ability to maintain the pH ataupun to resist the significant changes in pH. Okay, alright. So kalau you kena draw the pH curve, normally kita ada buffer region. Okay, so buffer region is either dekat atas, dekat bawah ataupun dekat atas. Dia depend, dia tak semestinya dekat bawah. This is just an example, guys. Okay, so you have to identify the component ataupun component yang available di kawasan ini. Ataupun lagi satu, dia normally ada dekat atas. Katakanlah kan, dia ada dua possibility. Sama ada dia duduk dekat bawah ataupun dekat kawasan ni ataupun dekat atas. Okay, dia duduk macam ni, dekat atas atau apa. You kena identify. Okay, macam mana nak identify? You kena identify, maksudnya, okay, kalau this is weak acid versus strong base. This is strong base dekat atas, strong base dekat flask kan, sebab dia start daripada sini turun ke bawah. So dekat sini ada apa? The moment dia start neutralize, kita akan ada strong base berlebihan dengan salt. You kena determine based on this one. Bukan just simply hafal boleh lah, tapi ada tendency you akan salah juga kat situ kan. So you kena tahu, you kena determine. Okay, at this region, siapa yang ada pada ketika ini? Okay, the moment kita titrate, okay, kita drop by drop kan, titrate, we titrate, but still the base is still available, strong base. Sebab kita guna strong base, katakanlah guna strong base. So the moment they neutralize, it will produce salt. So what we have in this region is strong base and dengan salt. So is this considered as buffer? No, this is not buffer. So most likely dia dekat bawah ni. Again, you kena ni lah, identify lah. Okay, once they dah go through the equivalent point, that means both acid and base dah habis, and then we still keep titrating. Kita tetap masukkan titrant dekat situ. Okay, at this point, siapa yang ada dekat dalam at this region? Salt memang confirm ada. The moment dia neutralize, it will produce salt. Tapi how about yang lagi satu spesies tu, siapa yang ada? Okay, so you kena imagine step by step bila dekat curve tu, okay, kat sini siapa yang ada? Siapa yang extra? Siapa yang available at this point? Okay? Right. Wih, alamak, 3:59. Guys, do you have class after this? Every time saya tanya soalan ni, setiap kali tu saya lupa. Tak, after class saya ni, ada kelas ke?
Tak ada.
Ni siapa yang cakap S14 ke S13?
S13.
Okay, how about S14?
Tutor terkira ke tak?
untuk pukul 5. Kan? Tak ada kejap saya 5 minit minta izin dulu. Okay, nak bagi samakan dengan S19 dengan S20 so that esok saya nak combine lecture. Okay, saya nak buat 2 hours planning 4 to 6 lah macam biasalah. Okay, selagi kita tak habiskan topik 3 ni. Okay, geram je saya Okay, last one. Okay guys, last one. Last one. Okay, how does buffer works? Apa beza yang ini dengan yang slide yang tadi? Guys, yang this one is actually the same. It's just that the contoh. We have the contoh example given to us. Tadi in general, you notice tak? This one? Dah macam apa dah ni? Dia punya equation dia, see? General equation. Okay, alright. And this one, dia dah start bagi contoh. Okay, alright, so let's go through it together. Okay, the buffer component, this is subject to acidic buffer. How do we know this is acidic buffer? Because this is an acid. Okay, so this is weak acid. This is the salt ataupun the conjugate base. Okay, the salt that contains the conjugate base. Okay, so the buffer components of these are able to consume small amount lah. Okay, small amount of added OH minus dengan H3O plus. Kalau banyak sangat letak acid base kat dalam tu, dia pun tak tahan. Okay, ini macam buffer. Buffer ni macam kalau laptop kita tengah buffer ataupun loading kan dia macam pusing. Dia macam tengah absorbing. Macam you tengah buffer lah, tengah absorbing the information yang given from me. Saya bagi kat awak ni, buffering slow je. Okay, sebab you tengah absorb. Tengah sikit-sikit absorb, try to absorb apa yang Madam cakap ni. Benda Madam cakap ni kan. Macam tu lah contoh buffer tu. Okay, tapi kalau dia lebih daripada kapasiti yang dia tak boleh nak tanggung tu, nanti dia mula, dia hang. Dia hang. Itu nanti dia hang, lepas tu dia crash. Crash tu yang kita tak mau. pH increase drastically, pH decrease drastically. We don't want that to happen. Okay, small amount. Okay, dia hanya boleh counter small amount saja. Dia pun tak tahan. Okay, sebab masuk serang. Lama-lama habis lah dia kan. Tu contohnya. Okay. So, are able to consume small amount of added OH minus or H2O plus by a shift in equilibrium position. So, we are still going to relate this reaction with equilibrium position. Okay, shift in equilibrium position. Okay, alright, so this is the equation, that the general equation just now. Okay, so this is more specific because we have the acid given to us. Okay, so this is the acid, the dissociation of the acid. Okay, kita boleh pakai the dissociation of the acid so to represent the buffer. Okay, sebab apa? Dalam dissociation of the acid punya equation ni, dia ada acid dan dia ada conjugate base. Dia ada dua-dua tu serentak dalam satu equation. That's why we can use this dissociation of the weak acid as to represent the buffer. Okay, sebab dia ada dua-dua tu, nampak? Okay, alright, so this one, apa nak cakap tadi? Added OH minus react. Okay, so what happen if we add in OH minus? We kacau the buffer, we disturb the buffer by adding OH minus. Okay, so when we add in OH minus, guys, of course the weak acid in the buffer will have to cover, we have to counter attack that base. Betul tak? Dia kena neutralize lah, counter attack. You jangan pakai counter attack dekat dalam exam you kena cakap neutralize lah. Ini saya gunakan perkataan-perkataan fancy so that you be easily remember ataupun nak memorize. Okay, tapi dalam exam janganlah counter attack, pakai apa perang-perang punya ni jangan. Okay, added OH minus. So this will react with the weak acid. Okay, when these two are reacted, they neutralize kan? They neutralize and it will produce this one. See this one? CH3COOH. It will react with OH minus to produce, see? It's the same ion, right? See, nampak ni? So they produce this one. So this cause a shift to the right. Dia akan ke kanan. See? Okay, attack ni faham So weak acid dia akan react dengan OH minus. So this is the equation guys. This is the equation. Kalau you are asked to write the equation. So this is how you should be writing the equation. Macam ni. Dia akan produce minus. Dia akan ambil this H bagi ke OH minus jadi H2O. So this one become minus. But how about in terms of equilibrium shifting? Okay. Dia akan shift with subject to this equation, dia akan shift to the right because this react with this one produce this one. So dia ke kanan. Shift to the right. Okay. Alright. So how about if we add in H3O+? Kita kacau this same buffer by adding H3O+. H2O+ is an acid, right? So nak counter the acid, kita kena react with base. Base from the buffer. So siapa yang behave sebagai base? This one, dia behave sebagai base. So this conjugate base, CH3COO- will react with H3O+ added to produce CH3COOH plus H2O. So H from the H3O+ will be given to the CH3COO-. Okay, alright, so if this is the reaction, the equation, if you are asked to write the equation. But in terms of shifting, guys, okay, you need to use this one, your dissociation of the weak as your reference, as your equation, a reference equation. So dia akan shift to the left. Okay, they shift to the left. Sebab apa nampak tak? Dia produce CH3COH. Bila you buat equation, you produce this. So CH3COH kat mana? Kat belah kiri kan? So dia akan shift to the left. Okay. Right. So that is all.